verifying identities, and everybody desperately loved it. The crowd went wild. Is that not true? It's not true, it's okay. But I hope you take it to heart what I was saying. And very often, it can get frustrating, just to let you know. When you have a quiz, like the one we're going to have next Tuesday, and you have to verify identities, I'm going to grade much more heavily on, can you show me you remember the identities that we went over? So we're going to do some more today. And do you know how to try to apply them? Even if you don't get to the end of the problem, even if you don't get one side to make it look like the other side, you could still get most of the points if you show me, I know sine squared plus cosine squared is 1. I know this, I know that, I know what to try to do, and if it just doesn't work, you'll still get a decent chunk of the points. Because it's frustrating as hell when it just doesn't click, or you try something and you wrote something down wrong, and then you thought it was the wrong way to go. That can happen. So I try to grade heavier on concept and allow for room for human error. So it can get really frustrating. Okay. So just keep that in mind. You're always, never fully erase everything you've done. I've had that people do that. I'm like, I can almost see this. It looks like it was good, but I can't tell. So minus everything. Damn it. Leave something that you're doing so I can see you're trying the right thing. Any questions from homework before we jump back? And everybody saw this, yes? There's only one other person that's come in since. Jai, you saw that, right? Yes, okay. Like the thing that's surrounding me? Yes. So we're about to do something today that I really am sad that so many people are missing out on this, but it's relatively early still. It's only 5 minutes after class starts. If there are no questions, well, let me do this first before I jump into some freaky stuff. We're about to do something with this. Okay. Can somebody remind me what 1 plus tangent squared is? Secant squared, he said as he looked down in his notes. Okay. Which is fine. I mean, right now you don't have to have these memorized, but probably by the day of that quiz, you should have these memorized. And then what's the other one? Somebody else tell me the other one. Are you somebody else? How many personalities do you have up there? What is 1 plus cotangent squared? Good. And that's a beautiful analogy there between the non-cos and the cos. Do you guys see what I mean? Okay. And then of course we had the main one, sine squared plus cosine squared as well. And that's the one I would highly recommend you memorize and then you build, or you memorize all three. It's up to you. The other identities we know so far are, you wouldn't even think of them as identities necessarily, but here, you got the reciprocal identities. Sure. You got the tangent, cotangent, kind of like definitions of what they are. Yeah. So this is a beautiful example of an identity that we've talked about before. And the reason we call it an identity is it's not dependent on an angle. I don't solve this. It's not an equation to solve because it's just a statement of truth. So if I said 2 times x plus 2 equals 2x plus 4, that is not an equation. That is a statement of truth. That is an illustration of the distributive property. Okay. Yeah. So that's what identities are. So when we verify identities, you can't do something to both sides. I was in the CISL yesterday. I was there today, but yesterday somebody came in and he was doing stuff to both sides. And I said, you shouldn't do that. And he said, my teacher said we could do this. And I walked away. I went and cried somewhere. Because it seems like a silly thing, but you can't. You can't do something that depends on the equality being true if I'm trying to verify the equality is true. Okay. It's like assuming the answer. It's a fallacy. So let's do this. If there's no questions, I want to do one more thing up here with you that's going to be integral to this discussion today. This is going to seem very silly. I want to start with a concrete example. So we're going back in time. This is a beautiful time. Can you guys write? I don't want to know the exact answer. I don't want to know. Well, I do want to know the exact answer. I don't want any calculator. Just tell me how you would figure out how long the x piece is. How would you figure out what this is here?
7 cosine.
Yes, so I can't remember if I had talked about this yet, but if you do cosine of 50, that would be x over 7.
Yeah.
And then if you multiply the 7 up, yes? Did I talk about this already, where cosine is like a percentage of the hypotenuse that's in the x direction?
Maybe.
I think so. I remember looking at Christine when I said that, because technically it's not really true, but it's close enough that it actually makes sense, especially because cosine in the first quadrant has to live between like 0 and 1 in the first quadrant, so percentages are from 0 to 100%. So if I take 7 times cosine of 50, that's like a percentage of 7 that lies in the x direction. So in general, if I have a triangle, and let's say this is 1 and this is theta, what is x? It would be 1 times cosine, so x is just cosine theta. And y would be, that's insane. Let me take this one more step. Is everybody with that? If I made this 4, that would be 4, that would be 4. What do you do? Yes? So one more step, and this is going to freak you out. Whatever, Jeff. What if I had this? This is theta, and this, my friends, is cosine beta. Don't overthink it. What would x be? Cosine beta times cosine theta. Cosine beta is just some number, yes? You guys with me? I could have put a 7 there. Wouldn't it have been x equals 7 cosine theta? Okay, so whatever I put here, the x piece is that times cosine of the angle. So it doesn't matter what I put here. Yes? I could have put Trent here. Here, let's do it. Here. Trent, you are now here. This is where you live?
Okay.
Good. So what is x? Trent cosine theta. And what's y? Trent sine theta. Kick ass. Okay. All right. So let me give you this and let you just process it. Don't look on the back yet. So you guys will immediately look at the back. That's fine. A special place in my mind for you. So, guys, instead of just what I normally do, I did this earlier this semester with my morning class, the other one that's doing trig stuff. And I just sort of like, well, we have so much shit to do, there's no time for me to let them play a little bit. Can you guys first identify where there are right triangles? Just do that for yourself. Can you identify the right triangles? Don't say anything, don't tell me how many there are. Just see if you can identify them. And this would have been, I was thinking about getting like colored pencils or something. All right, does somebody feel like, and by the way, you might be able to see like little things that I erased. So I will do this later, but that right triangle doesn't exist yet. So not how many right triangles can you make, how many right triangles can you see? Does somebody have a number for that? I have 2, I have 3. 3, okay. For a minute, you raised your hand, I thought you were saying 5. Was that? There's more than 3. And the last one is a little evil. You might not tell. I have to pretty much tell it to you, but you might be able to guess where it is. So let's see, real quick. How many right triangles? Let me make sure you guys are with me. Let's do it this way, Jeff. Do you guys see, Jeff? It would be a lot easier over here where it's smaller. Good point. Do you guys see this one, the stocky dude? Yes.
Okay.
What angle is in his base? This guy.
A plus B.
A plus B, yeah. And here, do you guys hear? You guys hear that too, right?
No. That's crazy.
You should have all looked at each other and say no. It's just you, Jeff. Don't ask for whom the knocking is. The knocking is for you. Ah, shit. All right. So this one's got alpha plus beta. I'm going to keep these. For a minute, I was going to make this A and B. We can keep them alpha and a beta. Okay, I like it. Are you guys kind of with me?
Yes.
So this is something I've done for a long time. What is happening? This is something I've done for a long time to try to explore what happens if you put the sum of 2 angles into a sine. Like earlier this semester, we explored, what if you put a product into a log? What happens? And we did it, and we're like, oh shit, some stuff happens.
Yeah.
So now the question is, what if I have the sine? I'm upset at myself for letting it get to me, but it's getting to me. All right, I'll be right. Is it carpentry? What is that? All right, I'm sorry. So we're curious what happens if I put, and of course we're going to do the same thing for cosine. So I've got this right triangle that has alpha plus beta in it. And then I got a right triangle, like how many do I have that has alpha in it? 2, good. The shorter one and then the longer one, yes? Okay. And then there's one more that's a little tricky that you couldn't possibly tell just by looking at it. But I will tell you this is a right triangle here. Okay. Obviously, I'm just realizing I'm on the 2nd floor, Jeff, so it's not another classroom. Can you guys, okay, here's what I want you to do. Maybe with pencils so you can erase it just in case you guess wrong. Can you take any of your right triangles? Which right triangles do we actually know something more about them? There's only one other thing I told you besides those base angles, and that's the side of that one, the length of the one side, yes? How many triangles does that length live in? 2. Based on what we just did right before this, can you try to figure out some side lengths of any of the right triangles? And I'm going to go investigate for a moment, just for my own sanity. What we got? Oh my God. You're not going to believe this. So in the classroom next to us, it's some kind of anthropology or maybe geology class. There's all these students with like gloves on, and then there was like a tarp down or something on the floor, and they were just rocks. They were just bang, bang, bang. And there's another teacher who's downstairs from them, and they're taking a test. So he went in right before me, and I'm like, all right, I'm going to let him attack. And I looked at the students and said, tell your teacher to do something else with you. I'm like, I can't do this, so we'll see, hopefully. It looked really cool, by the way. I felt a little bad, but most of me felt like, please shut the hell up. So, we'll see. Okay. I can't imagine taking like a test underneath that class. Good Lord. Okay. Has anyone discovered anything?
I think so.
Okay. Dylan, you got something? Trent, you got something? Ronnie, did you have something?
Yeah, name some of these triangles with the, like say with the cosine with the
Yeah, so since we know the hypotenuse for a few of these right triangles, yes? For example, this one right here. This one right here, yes? Are you with me? So let me name these things. This is alpha plus beta. I'm going to call this J, K, L. Okay. Just kidding, lol. Okay. So JKL, triangle JKL, yes? This is the hypotenuse. What is this then? What is the X piece? Based on what we did just before this. What is this side?
Cosine A plus B.
Yeah, so from here to there, that would be the hypotenuse, 1 times cosine alpha plus beta. Is that cool? Based on what we did right here, this stuff. You guys with me? Now, I just want to warn you. We are going to fill this thing up. Every now and again, I'm going to transition, and let me make sure. Did I pick the... No, I didn't. I'll be all right. You'll be all right, Jeff. I'm going to transition to another sheet that's got, like, what we've discovered, but typed by a computer so you can read it. It's going to get a little messy. Just try to follow along. I really want you guys to be with me when we construct this. There are... Anyway, I'm not going to go over that. What about this, then?
Sine plus beta.
So I'm going to do this. This will be sine alpha plus beta. Yes? Okay. I think I'm going to put it out there on my, anyway, it'll be all right. So those are direct. Remember, when I have a right triangle and I have the angle and the hypotenuse, the x piece is hypotenuse times cosine of the angle, the y piece is the hypotenuse times sine of the angle. Since the hypotenuse is 1, I just get cosine for the x, sine for the y. What else can we do? What about this other triangle that also has a 1 in it? What's the angle in its base? Beta, yes? Beta. So what is this then? Let me rotate this just a bit.
Cosine.
It's got beta in its base. Let me make that a little more clear because this guy kind of bled through. Oh, there it is, there. And then this is all a plus b. Okay. This would be cosine beta. Is that cool? Same way. Nothing new there. So then what's this?
Sine beta.
Sine beta. That's crazy. Okay. So now what we're going to do, and by the way, let me make sure, yeah, okay. Cosine beta, this whole thing is cosine beta, yes?
Yes.
Okay. So looking at this, okay, is everybody with me still? I keep stopping because it's not the most important thing that you know every step I'm about to do. We're deriving a very important set of identities. And they're going to be used throughout calculus. However far you got to go in calculus, they're going to show up whenever they want to. So I really want you to have a grounding that where these things came from, because they are not obvious. I can't just put them on the board and go, well, yeah, obviously this is true. No, they don't make a damn bit of sense if you just look at them. We got to know where the hell it came from. So look at this triangle now, this bigger, longer dude, yes? This guy. This guy, is everybody with me? Let me call these something else. Call this Q and I'll call this R. So now I'm looking at triangle JQR, yes? JQR. Is everybody with me? What is his hypotenuse?
Cosine B.
Cosine beta, yes.
Beta.
So then what is this? We talked about this before. What is his angle, by the way? What is his angle? What does he want from us? No, I mean, what's the angle in his base? What's the angle in the base of this guy? Alpha. So now, don't overthink this. What is the base of this triangle then? Cosine beta, cosine alpha. It's the hypotenuse times the cosine alpha. How do I always find the x side? The hypotenuse times the cosine of the angle in the base. That's exactly what we just did. Our hypotenuse is just weird looking. Our hypotenuse is cosine beta. It's not its fault. It's just what it is. What is this then? This length?
Cosine beta.
Yeah, it'll be cosine beta sine alpha. Because the y piece is hypotenuse times the sine of the angle in the base. And just to really say this one more time, you're never going to have to do this yourself. Yes? So don't over worry about this, but also don't under worry about this. Try to make sure that every step we take makes sense. How are we doing so far? Okay. Let me see. I want to make sure before I could. Yeah, I think we got everything I need before I go there. There's one more thing that I want to let you guys think about. And don't say anything if you figure that out. Keep it yourself. You can motion over to me. I'll tell you if you're right. I want to know. Have you ever seen the right? No. I am going to make a right triangle here. And I want to know what that angle is right there. And I'm telling you right now that I've given you enough information to figure it out. I want to know what that angle is right there. Don't say anything if you think you figure it out. Just call me over. I can tell you if you're right. But please, just even if you don't have a clue what the shit to do, just start playing around with it. I've given you enough information to figure that out. Believe it or not. I'm not saying it's easy. I am saying it's doable. So just give it a try. Does anyone feel like they're going in a good direction, or does anyone feel like they want to hit? Is anyone just waiting for me to talk about it? Yeah, what's up? We don't really have any. I don't want the number. I don't give us enough information for that. I want to know what that is in terms of these, because this is the only thing we know about angles, right? So, for example, this is a right triangle here. That is beta. That is 90. What is this whole thing? I mean, you can start to kind of like swing around and get more and more information about that corner. Yeah. I can't remember that's necessarily useful. Well, yeah, it is. That's right. Yeah, that's all we got to do. For a moment, I forgot to do it. It does. Trying quieter tabs. Yeah, where Dave asks. Me and that other dude.
I think if it's meant.
And you have like a mark on your floor, like they.
Well, I don't think it's anthropology. I think it's probably geology, which would make more sense.
Yeah, I was gonna say if it's anthropology, maybe we can expand it and try to replicate, the flint accents that people.
Are they trying to set fire? Is that what you're saying?
No, I mean, make like a, yeah, basically.
Oh, that's hilarious. I would have so much fun in that class. Hop around.
Yeah, I think they would be banging the rocks together.
Have all the students gather around me. Oh, we big tools. Alright, sorry. Maybe not. I don't know. Alright, guys. Anyone feel like they're getting closer?
Yes.
Okay. Let me help one thing. Everybody agrees with me that this is a right triangle here. Especially since I drew that there. This one right here. JKQ. So this is beta down here, right? And this is 90. So what must this whole thing be?
180
Yes? 180 minus 90 minus beta, which is 9. So it's 90 minus beta, yes? 180 minus 90 is 90. So this whole thing is 90 minus beta, yes? Now, isn't this a right triangle? Yes. What's the angle in its base? Alpha plus beta. So then this piece has to be 180 minus 90, which is 90, minus alpha plus beta. So this piece right here is 90 minus alpha plus beta. And you're all exactly as excited as you should be. So that wasn't that crazy. I had two right triangles in which I knew two angles. So of course I can get the third angle. I want that piece. We know this and we know this. So how do I get that? If I know the whole thing and a part of it, I just have to subtract. So if I take the whole thing minus the part, can anyone help me do this? If you want to be careful about it, you can distribute the negative. Negative times negative is positive, is that cool? The 90s die, what else dies? Oh, poor little beta. So this is alpha. So that has gotten very messy. So now I'm going to bring in, let me make sure I got everything on here. Yes. I'm going to bring in this guy. It's a cleaner version of everything we just discovered, yes? So now this should have everything. Did you get everything, Jeff? I think I did. I did. Look at me go. Okay. And now I've got this drawn in, making this a right triangle here. So let's focus on this little dude because we just got that alpha in there. We all feel pretty good about that. Can somebody tell me what this is? Don't overthink it. What's the hypotenuse in this triangle? Sine beta. So how do we get the x piece? The angle is alpha. Sine beta, cosine alpha. So what's this piece? Sine beta, sine alpha. Okay. It's getting more complicated because we've just done triangles inside of triangles inside of triangles, and part of you are sitting there going, oh my God, man. I knew this is what math people do, is sit around thinking, how can I make this more complicated? These damn students have got to make their life worse. All right. What else do I need here? Blah, 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 blah. Do I have everything? Really? Is that all that was about, Jeff? Sorry. I do have everything. So, watch this. This is so cool. I want to know what sine of alpha plus beta is. And if I do this, what makes sine alpha plus beta? What goes into this whole thing? What sides go into making this length?
1.
No, there's no 1. What makes this whole length? So I start here and I end here. Yes, that's the, yes? So sine beta cosine alpha, yes? Plus sine alpha cosine beta. So this will be sine, I'm going to write like this, alpha cosine beta. I'm going to go up. Sine alpha cosine beta plus sine beta cosine alpha. Ooh. Okay. Okay. And then if I look this way, I want to know what cosine of alpha plus beta is. Do you notice how cosine is kind of like the other way around? What's the full side is cosine alpha cosine beta, yes? And then what do I do to it to make it just become this long? How much length do I have to subtract from this guy? I'm going to subtract this length, yes? What is this length? Sine beta sine alpha. I love it. Let me bring this one in. This is same stuff, just written better. So we got, oh Jeff, you already wrote this over there. I'll be all right. No, alpha, Jeff. Okay. And then if I look this way, cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Wow. So here's an immediate thing. What do you think sine alpha minus beta is? Well, let's do it directly. This would be sine alpha cosine negative beta plus sine negative beta cosine alpha. Does anyone know what cosine of negative beta is equivalent to? And the way I keep this straight in my head, if you know what cosine of 10 degrees is everybody with me? Is cosine negative 10 degrees different? They would have the same x length. In fact, they would be the same sign, SIG. So cosine of negative beta equals cosine of beta. They're the same. But what about sine? Does sine work that way? Sine of negative beta, whatever sine of 10 degrees is, how does it relate to sine of negative 10 degrees? Whatever sine of 10 degrees is, how does it relate to sine of negative 10 degrees? Where's negative 10 degrees? What quadrant? Fourth. What is the value of y there? What's true about it? Negative. So what would sine of negative 10 degrees be versus sine of 10 degrees? Negative. So sine of negative beta is negative sine of beta. Just go with me. Go with me. I have a beautiful way to remember this. We'll see if you agree with me. I can do the same shit with cosine, and what I end up with become a beta. Cosine alpha cosine beta plus sine alpha sine beta. So here's the way I look at this. You know I have a weird little way to look at this. I'm going to consolidate all of this, okay? Shit. On some preferably blank paper. Where did I put all these? There you are. Sine is the nice guy. We have given Sine 2 toys to play with. And what does Sine do? He says, hey, cosine, come on over here, man. I'm going to play with alpha, you play with beta. Right? We'll take turns. I'm going to keep it a plus sign because I'm a nice guy. And then I'll play with beta, you play with alpha. This is just, obviously, a way to kind of remember it. There aren't little sine and cosine monsters playing with toys somewhere, as far as I know. Could be in that room. Who knows what else is in that room? Who knows what they're cutting? Something comes out of the rock and it's a horror movie. Anyway, we'll be all right. And if this is minus, it stays minus. Do you guys see that? Cosine is an asshole. Cosine is given 2 toys, and it says, I'm going to play with both of them. Man, you got a plus sign? Screw you. And then it's like, I'm done sign. You can play with this shit now. Okay, the psychology of trig. So if that was a minus, this would be a plus. So it's just a way to remember. And the funny thing about, I'm pretty sure I told you guys cosine's an asshole. Have I told you that? Okay, it's a true thing. And it's really funny how long that goes for. Cosine continues to be an asshole into calculus and beyond. You'll see what I mean. It kind of helps to remember some of the stuff with cosine. So let's do a concrete example, dear God, Jeff. Actually, on the other side of this paper. No, let's not do that. Here, perfect. Is it the same problem? No, I love it. Cool. All right, I'm so happy. So if you have your lecture book, if you need copies, I have 2 more of these, I think. Somewhere. There they are. So if you need module 13, if you have your book, that's where we are. If you need a copy, let me know. I love you guys. There's so few of us, and yet we sit so far away from everybody. Okay. Sine of 15 degrees. Before today, ain't no way in hell we get that by hand. Plug that thing in the calculator. Could we take a decent guess? Yeah, we could take a, in fact, what is sine of 30 degrees? 1/2. So if I had to guess sine of 15 degrees,
Less than 1/4.
what's the 1? You might say 1/4. That's not a bad idea. It's not a linear relationship, so it won't be 1/4, but 1/4 should be kind of close. I also don't care that the calculator gives me a number, because that number is rounded, therefore it is wrong. I want the exact right answer. Yes? And you guys are like, well, that's too bad for you, Jeff. No, but we can do it now. Is 15 degrees either the sum of 2 angles we know, or the difference of 2 angles we know? Are there 2 angles that would add to 15 and they're ones that we know, or that would subtract to be 15 and they're ones that we know? 45 and 30. So I can write this as sine of 45 degrees minus 30 degrees. Do you see how you could have also done 60 minus 45? You could have also done all 135 minus 120, although I don't know why you want to go out of the first quadrant. That's crazy. But it would come out to the same answer. How can I immediately rewrite that? What is A? What is B? This is minus. Sine's the nice guy. So what does sine do? Given 2 toys, being subtracted, what does sine do then? Because he's the nice guy.
Sine 45.
Yeah, he plays with this guy while
Yes.
Cosine plays with the other guy. That's a minus. He's a nice guy, so he keeps it a minus.
Yes.
And then they change toys. Each piece of this, is it something we know? The answer is supposed to be yes.
Yep.
Go ahead and see if you can do that. Notice those are multiplying, and there's a minus sign in the middle. Go ahead and see if you can replace it and simplify it a bit. By the way, I am not going to make you memorize the tangent. One big reason is because I don't have it memorized. I never make you memorize what I don't have memorized. But also because other instructors in the math department will not assume you know them. It's a decision the math department made. Which I'm very happy about because I didn't want to memorize the exam things. So let me catch up to you guys. What is sine of 45 degrees? Yeah, rad 2 over 2 times, yeah, minus sine 30 is just, and cosine of 45 is, of course,
Yeah, so then what is rad 2 times rad 3? Half of 2 times half of 3 is... What's a whole 2 times a whole 3? 6. So what's half of 2 times half of 3? Half of 6. Okay, what's 2 times 2? Holy shit. And then 1 times rad 2 over 2 times 2. There you go. Can somebody
Put that in their calculator and see how close Dylan got with his very good guess about 1/4. Let's see how close this comes out to be that. We're not going to give him any shit if he's really far away. I'm pretty sure it's semi-close to that. 0.35, and 1/4 is about 0.25. That's pretty good for government work. Are you guys all with me? If you want to, if you have a calculator, try to see if you can get that same number. Yes. Square root of 6 divided by 4 minus square root of 2 divided by 4.
I got 0.25.
Ooh, you're even better. Do you see what you did wrong?
Yeah, I just did.
I don't know the answer, so.
I just did square root of 2.
Oh shit.
I don't know why.
So 0.258?
0.25.
Damn, your guess is even better. So you just, it sort of averaged out. The mistake you just made and the fact that you got really close. Okay. Yeah, I thought it was supposed to be closer, but. Can somebody also, is everybody with what's happening? We just put that in to see what the number actually was, sort of. Can you do sine of 15 degrees? Because that's what this is supposed to be, right? Let's see if we still get 0.258, roughly. What'd you get?
0.650.
Are you in degrees? Well, there's your problem. Yeah. So just really make sure everybody follows. If I do the square root of Jeff. Oh, there's everything. Square root of 6 divided by 4 minus square root of 2. No, Jeff. Square root of 2 divided by 4. You get 0.2588, blah, blah. And if I do sine of 15 degrees, I get exactly the same thing in terms of how far my calculator can go. So we did, now listen, as a student, you're like, why the shit don't we just put it in calculator, man? Isn't that, look Jeff, look, that's pretty good. There are many instances in the world where if you use any estimation before you're done, the answer is going to be way the shit off. You're going to be completely wrong. So very often, especially in certain STEM fields where you have to be very precise, you're never going to use a decimal approximation. You're going to use this, because this carries all of the information with it. So it's not going to have an error that gets worse. So if I used 0.26 instead of 0.2588, blah, 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 that's pretty close, yes? But if I multiply that by 1,000,000, then it's going to be really far off from what it's supposed to be, yes? So the more I do with something that's an approximation, the worse the error gets. It's called error propagation. Okay, listen. Just so you know, there's a reason that we want to be able to get the exact answer for something by hand, instead of just relying on the decimals the calculator gives me. How do you, I don't know. Can you do this one without leaving radians? I don't want you to convert it to degrees. You're like, I don't know, Jeff, what the shit, man? How do you even think about this problem? What bottoms do we know in terms of radians? What denominators show up in the angles we know for radians? Pi over 4, pi over 6, pi over 2, pi over 3. Yes? Don't some of those go together and make over 12 with the LCD? So I want you guys to take a few minutes, try to figure out, is there a way to write this as like something over 3 plus something over 4, or something over 2 plus something over 6? Something, yes? Right. Try it. And
There's a very, well, we'll see. We'll see what you guys think. One way to do this is to think about 7 and then think about how many ways can you break that up. So for example, 7 pi is 1 pi plus 6 pi. So it'd be like pi over 12 plus 6 pi over 12. Well, that sucks because I don't know shit about pi over 12. But then try something else. Really make sure you guys are with me. This is a true statement right here. But this statement sucks because I don't know shit about this angle. I need to know something about both angles like we did up here. So somebody have a better way to do this? What would you try next? You would try 2 pi and 5 pi. And then 5 pi over 12 sucks. I don't know anything about 5 pi over 12. So this is bad. This becomes pi over 6. That's awesome. But this, I don't know anything about that. So what's the next natural thing to try?
3 pi over 3 and 4 pi over, or sorry, 3 pi over 12, 4 pi over.
Right? That's 7 pi over 12. And what is 3 pi over 12? Reduce it. And what's 4 pi over 12?
Pi over 2.
Good. So what is the cosine of 7 pi over 12? It's equal to the cosine of pi over 4 plus pi over 3. Do you guys follow? You can literally just kind of guess a little bit, and then you start to see how you can get it closer and closer and get there. Now take a moment, try to use the identity we just created for cosine of a plus b, and try to figure out what that is. Yeah. There. I can't remember if anybody missed out on these announcements. Quiz next Tuesday, 9192, and no class tomorrow. Okay, and if you hate that I'm giving you one day off for the semester, like I paid for the whole class, then, go report me to my dean. He wants to fire me, so give him a reason. I've had people get upset at that, by the way. So cosine is the asshole. So how do I rewrite this? So what does he do? What makes him an asshole with these two things?
He goes first on both.
Yeah, he goes first on both. He takes both toys. He plays with them until he's done. He sees a plus sign, and he makes it. What's he make the plus sign? Makes a minus. He's a complete asshole. And then since he's done playing with the damn toys, he's kind of roughed them up. The toys don't even work anymore. He says, all right, sign. You go ahead and play with them. Now, I'm really sorry if my little stories I create are not hitting for you, but I almost don't care. I like this idea. Cosin's an asshole, these are toys I'm giving him, and then that's exactly how to set up the equation. And then each one of these, you know all this stuff. And the funny thing is you keep getting these same things because there's only so many angles we know. So what's cosine of pi over 4? 2 over 2. Cosine of pi over 3, that's closer to the y-axis. So cosine likes x, 1/2, so he's small, yeah. Sine pi over 4, that's where they both agree. And sine pi over 3, sine loves it there. Square root of 3 over 2, that should be a times sign. So then it gets root 2 over 4 minus root 6 over 4. Woohoo! By the way, what part of this makes sense? That's a weird way to say that, Jeff.
Can any of you tell me what quadrant this original... In fact, the problem we just did is the same all the way through. We just made it look different. What quadrant is the question in? Second, because it's a little past 6 pi over 12, which would be pi over 2. So it's in the second quadrant. Are you guys with me? What's true about cosine in the second quadrant? Negative. Without putting in your calculator, how can you tell this is negative? This number is smaller, so I'm taking a bigger away from a smaller, so it comes out negative. So it makes sense. I'm in the second quadrant. Whatever answer for cosine I get, no matter what weird shit I do, it better be freaking negative. Because we already know it's supposed to be negative in the second quadrant. Okay, maybe. It's a really interesting time coming.
Yeah.
We're doing, this is module 13 in the lecture book. I don't know if you need a copy, I can give you one. Module 13. Stay with me now. Example 12 is something that math, we do all the time. We're like, whenever you learn some truth, it works both ways. Yes? Math goes both ways, so be jealous. But how can I put this back together? What is this in the form of? What goes cosine, cosine, sine, sine?
Sine A plus.
No. Sine is the nice guy. Cosine here is going first. So it must come from cosine, yes? Yes, and it must be minus because cosine is an asshole since it's a plus. So this comes from cosine of 40 minus 10, which is cosine of 30. And what's cosine 30? Okay. So exciting. Okay, so let me come back to this. So already got this? Okay. Maybe. What you got? So let me write this now with less Greek. Let's see. Okay, I'm going to do something a little weird.
What if both angles I put in here are the same angle? Right, so it's like I put in there 15 plus 15, so that'll be 30.
What if both angles are the same angle? So in that case, let's say they're both theta. So that would be sine of theta plus theta. So what would that be? This is almost silly, but it doesn't matter what A and B are, this is true. So could they be the same thing? Of course they could be the same thing. This is a true statement for all angles. So that'd be sine theta cosine theta plus sine theta cosine theta. What is sine theta cosine theta plus sine theta cosine theta? How many sine theta cosine thetas do I have? This is 2 sine theta cosine theta. And what is theta plus theta? So what this is, you're not going to believe this.
The creative geniuses that are math people, we said that's the double angle formula because it's got double angle. That is the double angle formula for sine. What I want you guys to try to do right now is to figure out the double angle formula for cosine. Go for it. Exactly the same way I just did. Start with cosine, and then do everything I just did. I want you to know the double angle formula for cosine.
Do it exactly the same way. Where does this go? Good. Perfect. Okay. Oh yeah, that would have been smart. Darn it. Well, let's do that. Okay. Oh yeah, I could do that. Okay. So if I start with this, stay with me. And I do theta plus theta, and I just plug it in. I don't even worry about what's going to happen. I just plug the stuff in. What is cosine theta times cosine theta? Cosine squared theta. Sine theta times sine theta. And theta plus theta. 2 theta. You start thinking that you have a lisp if you say theta too much.
That, when I first was taught this,
It tripped me the shit out, because what do you get when you add cosine squared and sine squared? And when you subtract them, you get this thing. That is funky.
but it's true. It just is true. Everything we did today led us to this. Now here's another example of why cosine's an asshole. There are 2 other ways to write what we just did. Do you have to? If you want to pass the course. I give you lyrics. It's different.
So, what is cosine squared, for example? What can I replace cosine squared with? The most basic identity. Go ahead.
1 minus sine squared.
And what is 1 minus sine squared minus sine squared? How many sine squareds am I subtracting from 1?
Oh, 2 sines.
There's another way to do cosine twice theta. And there's another one. Another one. Another one. So if I start here again, yeah, now we replace sine squared. What can I replace sine squared with? Oops. And if I distribute the negative sign, minus a negative is plus. So I get 1 cosine squared plus another cosine squared minus 1. What the shit? So you get, here, if you want to see it written a little better, it's in your module on the next page. So there's 3 options. So when we see like a double angle formula in an identity, sometimes any of these work and sometimes only one of these work. And that's another place where if I'm trying to verify an identity, I could potentially pick the wrong one first. And that's fine. Because now I have only 2 things that could be. So let's try a couple things out. Oh, this is getting too far ahead. Is it? Maybe. No, it's fine. How do I find, if I know sine theta is 4/5, I know basically everything about theta, because the minute I write this, what can you guys create? The triangle. Where's 4? And where's 5? And you should know what this has to be. Something 4 or 5 triangle. 3. Did you know or did you guess? You know? Okay. The way he said it is like 3. Why not? So, what does sine 2 theta? What's a way to rewrite that? Because do we know shit? Here's theta, right? Here's theta. It lives in that triangle. Under the sea. Do I know what triangle 2 theta lives in? I have no freaking clue. I could like draw it, but I don't know shit about it. But can I rewrite sine 2 theta so that everything is in terms of theta? Because I know everything about freaking theta. Yes? I know everything about theta. So yeah, just like Trent said, sine 2 theta is 2 sine theta cosine theta. Sine theta, they told us. What is cosine theta? 3 over 5. 2 times 4 times 3 is 24. 5 times 5 is 25. Bam! So this is like a base level of how to use double angle formula. Yes. And then you do something very similar with these other ones. It almost doesn't matter. By the way, have I said this? I'm not going to make you memorize these. The tangents. Oh yeah, I did say that. I don't have those memories. Don't worry about it. Same thing here. Dear God, we haven't done these yet, but look at that. Yeah. Okay. Woohoo! So let me do a couple things, and then I have a handout for us. I want to make one thing really clear. Sine twice theta is 2 sine theta cosine theta. So what is sine 4 theta?
Sorry, Ronnie. I knew somebody. Listen, that's a beautiful guess. There's not a damn thing wrong with that guess, except it's wrong. Where did that 2 come from? Because it had 1 sine theta cosine theta plus another one. So what does this really say? This doesn't say whatever number's here goes here. That's not what this says. That will always be 2, because how many parts are there to sine of a plus b? 2. What happens to this angle when I put it over here? That angle is how related to this one? You could do it. That's twice theta. That's theta. How is that related to this? Half of it. So now I'll try it again. How would I rewrite sine 4 theta using the identity? I'll start it off.
2 sine 2 theta.
Yes.
Cosine.
Yes. Now listen, it's not your fault. And Ronnie, I really want you to understand it's not your fault. It's that I have to show this, or else it makes sense why would you think it worked another way. Because it's a pattern, and that's what math is. You're looking for patterns. But it wasn't enough of a pattern. It's just one piece. It's not enough of a pattern. Now you have enough of a pattern. Why is it always 2? Because sine a plus b equals stuff plus stuff. 2 things. So that's always a 2 in front. Always. What changes? The angle gets cut in half. Okay, maybe. All right. Yes. That's a good place to stop and give you this. Not that. Oh, on the other side of this. So everybody's got this, yes? Does anyone need this? Everybody got this? Okay. On the other side. Try out C and D. And you can, oh, you need one? Do you have to? So let me or Christine know if you need help. This is the same stuff we were doing yesterday, so you can't do stuff to both sides. But do you see how you can identify
the stuff we just learned sitting in both of those? Okay.
Angelica, on the other side of this one, we're doing parts C and D.
Is this true? No, this. It's not true. Yeah, that's the one we just learned. Cosine of A plus B. Sure. Yeah, this. You see, I'm gonna go right back. I'm gonna print out the identity sheet. Yeah. It's rectangular. think this one might be a little bit harder, potentially. It shouldn't be quite. Why is that? I'm hoping.
So, a generalization I can make when you're given a problem like this, one other thing you look for, one of the very first things you look for now is everybody talking about the same angles? These guys are all talking about X and Y, but this guy is talking about the angle X plus Y. Completely different angle. If X is 11 and Y is 7, this is 18. That's a completely different angle. So I want to rewrite him in terms of the angles everybody else is talking about. That's the only way that side could equal that side. Same thing over here. Everybody's talking about freaking X, except for this dude. He's talking about 2X, what the shit. So if I can replace that with something about just X, then it has a chance to actually work. So one thing you look for is, are they all talking about the same angle? If they're not, you try to use an identity to force them to be. So what can I replace cosine X plus Y with?
Cosine X times cosine Y.
Good. Cosine's an asshole. Minus, because he's an asshole. Okay. All over this. Now here's the next level mistake students make. And again, I don't care what level of math you're in. I get people do this all the time, right? My 281 students, when they do this, I cry a little harder. What is being divided by cosine X? Everything. So you can't just kill these, because all of a sudden he's off the hook. Mathematically, that doesn't make any sense. But you can see how it's really easy for our brains to go, well, there you go, that just dies. So the better way to do this is to say, this guy is being divided by this business. This guy. And now you can now you can directly kill some shit. So what dies over here? Die. And what dies over here? Die. And then what's cosine Y over sine Y? And what's sine X divided by cosine X? Which is... Okay. So if you missed yesterday's class, I highly recommend you watch the video. You start with one side and you try to make it look like the other side. If at any point you get stuck, you can start doing some shit to the other side too. They just have to meet somewhere. Either one completely makes it to the other side, or they both meet somewhere in the middle. That verifies that the equality is true. Part D should be a little bit easier. We'll see if I'm right. Yeah, there's one thing to replace, and then a bunch of cancellation to do. And then it should be sitting right there for you. We'll see. Oh, and by the way, I gave everybody one of these. This is your one-stop shop. You cannot use this on a test or something. Yes. Everything above the dark black line has to be memorized. Or you have to have a way to remember it. Yes? So now I think we talked about almost everything except half-angle identities. We'll do that next. Don't worry about memorizing these. I don't have any of these memorized. Okay. Let me know if you need some help with part D. Sure. You could, but then it wouldn't go anywhere for you. Because then you would have two things talking about x plus y, but then you have everything else talking about just x and y. So there's no way to show they're equal if they're all talking about different numbers. But I like that. You're right. And that could be helpful at some point. This one, I don't think it's going to work. Yeah. Sure. All right, guys, help me out. What is sine 2x?
2x, 2 sine x cosine x.
And of course, what cancels here? I lose a 2, and I lose
Cosine.
1 cosine. And what is sine x over cosine x? Yep, check. So that one was, if you let it be, that one was nice. Be real careful. Students are always a little confused about when you have something else, a squared version of it. How do they interact? You just literally just lose one, or lose how many they got in common, right? One dies, one's left on the bottom. Bam. No, I really, now I'm thinking how you got to where you got, but it worked, whatever you did. Okay.
I cycled through like a cosine squared into 1 minus sine squared, and then I made it 1.
Oh,
1
that's not a bad idea. So you try to make this match with the function that's on top?
Yeah.
Okay.
And it ended up weird,
It did.
but it was
Weird.
inconsistent.
Yeah. So there are so many ways to do these. This is not the only way to do this. This is not the only way to do this. So don't give up on something you're trying if it's taking you a few steps. You could have gone kind of like a roundabout way to get there, but you could still get there. And the more you show me, the more evidence I have you know what to try to do, the more partial points you'll get if you don't get to the answer. Okay. We did stuff like this yesterday, so I'm not going to worry about these two at the moment. What about these two? Like, how would you do this one? Yeah. Yeah. All right, do that one real quick. And then we'll prove the last set of identities, and then we'll do this problem in a different way. Just real quick thing. Do you guys remember the day that I drew the triangles on the board and you created all the ratios you could? And that was all trig was, right? It still is. That's all trig still is. We've just kind of like done more with it. It's always kind of trippy to me. All right, keep going. So this one shouldn't be too bad. This is almost, I mean, the funny thing about these problems is you keep getting the same numbers because there's only so many outputs we know. There's really only 3 angles we know, and then the extremes, right? The 0 and 90 are on the axes. So there's only so many combinations of those. So these get kind of like, there's square root of 6 again. Yeah, you know. But let's see if you guys agree with me. So what would cosine do with these things?
Steal.
Takes it all for himself. Little jackass.
Change the sign.
Sees the minus and says, that's nice. And then says, all right, sine, I'm tired. You play with these things. So 45 degrees is where they're both at. 30 is closer to the x-axis, so cosine is bigger. Sine, 45 degrees is where they're both at. Sine of 30 hates it there, so I get my square root of 6. And I could do this if I wanted to, since they're both the same denominator. Now, real quick, I do want to point out one thing. We did sine of 15 degrees earlier, yes? Where was that? There it is. And we got square root of 6 over 4 minus square root of 2 over 4. And this was plus. Now, why does that make sense? Who should be bigger at 15 degrees, cosine or sine? Cosine should be bigger, because cosine likes x, and 15 is almost the x-axis. And sure enough, there, he's the plus, that's a bigger number. Sine is the minus, it's a smaller number. That makes sense. Now, I couldn't know cosine's bigger and get these numbers. Holy shit, but since I can get the numbers and go, okay, that still makes sense with what we know. So we did one like this already. I want to prove the last set of identities we have left. And it's really not surprising that they're the half angle identities, considering we have double angle identities. We would want to go the other way. And the really dumb thing about these, let me write this here first. I'm going to start with this. And the reason I'm going to start with this, cosine twice theta is directly related to cosine or sine, one at a time. So I'm going to write it like this first. There's 3 ways I could write this. I'm going to write it like this first. Let me really make sure you guys are cool with what I'm about to do. Can somebody help me? If this was cosine of 40 degrees, how would I write this other side exactly? Kick ass. Yes? Ooh. If this was cosine of 680 degrees, what would I put over here? 340. Yes? Is everybody with me? Of course you would, because this is twice theta, and that's theta. So whatever this is, it's twice what that is. So what if this is cosine theta? What would I put over here? Yeah, cut theta in half, yes? Are you guys with me? That just captures what you guys naturally did. Whatever the shit number I put there, you're going to put half of it here. So whatever shit number I put there, you're going to put half of it here, yes? All right, now here's where this gets really dumb. If I just solve for cosine of theta over 2, I made a half angle formula. I don't know if anybody really is with me, that's kind of dumb. If I have a double angle formula, I inherently have a half angle formula. I just have to kind of like solve it to go the other way. That's literally all we do to create the half angle formulas. So if I solve for this, how do I solve for cosine of theta over 2? What do I do first? Yes, I add 1. And then I divide by 2. No, Jeff. You can do it, buddy. And then what's the last thing I have to do? How do I get rid of the square? Square root. Plus or minus. So I get this. So I always have disliked, and I'm guilty of it right now, but that's because I want to match with what the textbook says. I always hated that we pretend like this is a whole different equation. You just sat there and realized we started with one we knew, and we just solved it for the other side. Is this really a whole different equation? No. Yeah. So again, if you don't want to memorize this directly, don't. Just memorize this one and create this one when you need it. Who cares? Now, if I wanted to get sine half angle, I would start with, where did I write it? Here, this one. And do you notice how it's negative? Whereas this one's positive. So the one difference that would happen, it would almost look exactly the same, except now I would have this, a minus sign right there. So notice how cosine is still an asshole. Cosine took the one that had a plus sign and gave sine the one that has a minus sign. Yes?
Yeah.
Okay. It gets a little weak there, but it's still an example of them being an asshole. Yes. Okay, baby. So how do we use this shit? So what if I wanted to know? What if I wanted to know the sine of 22.5 degrees? Do you notice how the sum formula for sine would not do shit for me? Are there two angles I can add or subtract that make 22.5 degrees and I know what they are? No, that wouldn't do shit for me. Are you kidding me? But if I think backwards, what angle do I take half of to make this? This is the sine of what divided by 2?
45 degrees.
45 degrees. So then I can use this, and I've identified what theta is, yes?
Yeah.
I appreciate it. And real quick, that plus or minus is not always there. That's a choice we have to make. What quadrant is the question asking me about? First, so then what do we pick? Positive. So that is not something you just write. It is a choice you have to make. What quadrant is the question in? Pick the appropriate thing. If I would have said sine of 100 something, you would have had to pick positive still, shoot. If I said sine of 200 something, that would be negative, yes? Okay, there, good job. I'll get there eventually. So now, this is where students, some of you have already done this, but this is where students dissociate a little bit. Because we've manipulated this shit so much, you're like, oh my God. But thank God I've shown you now that we're done with new identities. That's it. Yeah. And again, these aren't new. They're just this, rewritten. Ooh. So how do I do this? It would be positive, because that's the first quadrant. 1 minus what?
45.
Yeah, because we identified what theta is, and that's what we put in there. That's the power of these identities. They allow you to make the angle you're worried about into an angle you know. That's what they let us do. So what is cosine of 45 degrees? Don't write the plus anymore, Jeff. Now, is anyone else not like that? Or is it just me?
Do 1 minus square root 2
Some of you guys are like, leave it alone, Jeff. It's had a hard life. I don't like this because there's like fractions inside of a radical. What the shit? That's too much. Does anyone know how to get rid of that fraction besides erase it and hope I didn't notice?
You can change it to 1/2 minus square root 2
No. Still got fractions. So here's the standard way. It's not a bad idea because at least then I don't have a fraction inside of a fraction. But watch what I'm going to do. I'm allowed to multiply top and bottom of any fraction by anything I want to except 0. So I'm going to multiply by 2. 2 times 1 is 2. 2 times rad 2 over 2, those cancel. And then 2 times 2, you're not going to believe it, is 4. What's the square root of 4? 2. 2. What's the square root of 2 minus I don't know. That. There's a minus sign that kind of got hidden. There.
And then you can plug that in the calculator, go where the actual decimal is. That one's strict because there's a square root inside of the square root, but we can't do much with that one. We actually could, but we're not going to. So for example, if I gave you, let's try one more of these. If I gave you cosine of 105 degrees, can you guys, don't say anything, just try to figure out how to rewrite that. Try to set up the identity. That's good. And then try to simplify. There we go. So you see all you literally have to do if you can't. So on this one, I am saying use half angle. I should say that because you could break that up as 60 plus 45. But here I want you to use a half angle. So then you say to yourself, okay, what do I cut in half? And all you really have to do then is just double that dude, right? So if it's ever a half angle situation, you just double the angle you're looking at. And hope to God that Jeff did this right in his head and we get an angle we can do something with. So what angle do I put up here? 210. Yeah. Twice 105 is 210, so 210 cut in half is 105. So you just have to double the angle that's there. So how do you tell if half angle formula will help you? If you double the angle and you get an angle you know. Half angle formula will help you.
And sure enough, double 105 is 210. How do I know we know that 210? We know 210. What's the reference angle for 210? 30 degrees. It's 30 past 180. That's an angle we know. What? By the way, real quick, before I get too far away, what quadrant does the question live in? So what should the sign of the answer be? No matter what weird shit we do, the answer has to be negative. So when we go to write this, we're going to pick the negative option. This is cosine. Cosine is nice to himself because he's an asshole to everybody else, so he's going to give himself the plus sign. And now you just got to figure out what the cosine of 210 is. And if you need to, you can do the little picture. You go past 210, you know you're in this. Now this angle is in this third quadrant, yes? Yes, so 30 degrees makes cosine root 3 over 2. I'm in the third quadrant for this angle, so therefore the cosine is negative. Okay. So this is a really good illustration of not letting the whole problem dominate your thought process. When I write this stuff, I completely forget about every damn thing else except this guy. That's the only thing I'm thinking about right now. And the minute I figure him out, I just put him right there. And then I step back and worry about everything else. I think some students get stuck at looking the whole damn thing. And you're like, oh, I don't know. So now I'm going to do the exact same thing we did earlier. So I'm going to get negative. 4 square root is 2. 2 times 1 is 2. 2 times this cancels, so I get rid of 3, and I get that weird looking dude. Sorry. I did all that without you seeing it. Could you try to plug this in your calculator, please? Let's see what we can estimate this to be. Did I bring my calculator? Yes. So that's how you can literally put it in. Now, if you have an older calculator where the square root button, the square root symbol doesn't grow, that does kind of suck. You got to pay attention to your parentheses. But I think there's less and less of those out there. So I get this here. And then to make sure I'm in degrees, if I do cosine of 105, I get the exact same thing. And the crowd goes, all right. Okay. Yeah, so there they are, right there. So the plus or minus is a choice you have to make. It's not a part of the answer. It's one of those two is going to make the answer right. Cool. So we finally got the green sheet. So now I'm going to like say on the green sheet, and you'll know I mean this thing. So you got to memorize everything above this. I think everybody was here earlier. The quiz is next Tuesday, 9192. 92 just deals with double angle. I think 93 is half angle. So 9192 is just basic identities and then double angle identities. And like I think 92 is just A plus B, A minus B inside of cosine and sine. Gotta double check now. Whatever 92 is, it'll be in the quiz next time. Tomorrow, what's happening tomorrow? Nothing, good. Not for us. If you have other classes, please still go to them. But our class will not meet tomorrow. So enjoy that. And I'll see all of you next week. It's going to have to. Okay. Normally, if you do the quiz, that's what I do. The next test takes the place of that.
Thank you.
Sure.
We desire to inquire on, do you teach calculus?
Yeah. Oh,
Yeah.
I
Summer and fall this time around.
Oh, okay. Because
Yeah.
I remember I thought.
And I told you guys about the numbering, yes?
Yeah.
They changed the number.
Yeah.
C22, 10.
Yeah. Because
So much better than
I
what
remember
we,
I
what were we
talked-
thinking?
Yeah.
Yeah.
I talked to you about it before, but I don't think you had a fall class at that time.